All right. Good evening, everybody. This is Brainiac Tutors, RHEMA 9, and we are live. We're going live now, and we are live. So tonight we will be discussing quite a lot of things in chemistry, specifically for the sake of our JAMB students that are starting exams tomorrow. I want to believe you can all hear me loud and clear. Please, if you can, let me know that you can hear me loud and clear. If you can hear me loud and clear, please let me know you can. Right? Unmute yourself and let me know that you can hear me. Okay. This video is we are going to start the class. Okay. I can see somebody has just joined. You are welcome. Can you hear me loud and clear? Oluwa Busayo people. Okay, I hope you can hear me. Good. All right. Um, Trying to wait to get join, and so we can start.
àti ẹ̀ mọ̀ sọ̀jẹ̀. ó ṣe wá rí báyìí.
Okay. Now, Busayo, can you hear me?
Yes.
Okay. Can you tell me one or two topics that you maybe you have had issues with while preparing for your exams in chemistry? Are you there? Can you hear me?
Yes.
Okay, so maybe as I continue, if you have questions, there are topics you would like me to talk about, you will be able to ask questions on those topics, okay? Okay, good. Rakib, you are welcome. Henry Martinez, you are welcome. Oluwabusayo, you are welcome. I hope you can all hear me. Henry Martinez, Joel Chapin. All right, because of time, let us get started. I hope you hear me loud and clear. Now, tonight we'll be dealing with certain topics in chemistry. Let me get started with separation techniques. I will quickly answer questions on separation technique very quickly, and then I'll go to another topic. Now, when we talk about mixtures, all right, a mixture
Wọ́n
is
sọ bí
formed
bàbá
when
lè
two or more elements or substances are combined together. It could be physically combined. You remember a compound is formed when two or more elements are chemically combined together. But when we talk about a mixture, okay, it could be combination of substances. A part of that substance could be a compound, it could be just normal substances. So you need to know how to separate all these mixtures. So questions can come in the sense, um, questions like which of the following is the method for separating maybe mixture of water and petrol. Can anybody tell us what will be the method for separating water and petrol? Can anybody tell us? Mixture of water and petrol, what can you use to separate it? Okay, so listen up. Mixture of water and petrol can be separated using separating funnel. I hope you can hear me. Can be separated using what? Separating funnel. What is the meaning of separating funnel? Separating funnel is used to separate two immiscible liquids. three mixable liquids. So like petrol and water, can you mix petrol and water together? No. So you use separating funnel to separate three mixable liquids. Now you can also there is something called fractional distillation. Then there is simple distillation. So I'm going to differentiate between fractional distillation and simple distillation. Now, distillation is used to separate two or more mixable liquids. I hope you can hear me. Two or more mixable liquids. But what is now the difference between simple distillation and fractional distillation? Fractional distillation is used to separate two or more mixable liquids, okay, with a very close difference in their point. I repeat myself. Fractional distillation is used to separate two or more mixable liquids, all right, with very close boiling point. So, for example, petroleum is an example of a mixture that you can use fractional distillation to separate. If you look at petroleum, what are the products you have in petroleum, or what are the constituents that make up your petroleum? When I say petroleum, I'm talking about your crude oil. Okay, inside the crude oil, you have petrol, you have diesel, you have kerosene, you have bitumen, you have a lot of things that make up that petroleum. So you can use fractional distillation to separate them. But when we talk about simple distillation is used to separate mixtures of two or more mixable liquid, but with a wide gap in their boiling point. A wide gap in their boiling point. So example is water and alcohol, or water and ethanol. So they can ask you, all right, they can ask you what separation technique is used to separate water and ethanol. The answer will be what? Simple distillation. I hope you can hear me. If you are still there and you can hear me, please let me know.
Ah, you comment.
If you can hear me, please let me know. All right. The next separation technique I'll be talking about is chromatography. Chromatography is used to separate two or more substances that have color pigment. The word chroma or chrome has to do with color or pigment. So chromatography is used to separate a mixture of substances that have color. So they can ask you which of the following is used in a maybe dye producing industry. It is chromatography to separate pigments into different colors. So that is chromatography. I've spoken about fractional distillation. Okay, good. Rockib, you can hear me. Fractional distillation is used in petroleum industry, so they can ask you. Then I've spoken about the normal distillation or simple distillation. Simple distillation is used in distilleries. What's the meaning of distilleries? Wine production industry, where they produce wine, where they produce alcohol. All right. So what they use there is simple distillation. So I've also spoken about separating funnel. I've spoken about simple distillation. The next one I will talk about is evaporation to dryness. Evaporation to dryness, that is one of the, you use that in Gary process, okay? And it is used to separate a substance or a solute from a solution. So let me give you an example. If I have salt solution, I can separate the salt and water using evaporation to dryness. And that is how the salt is gotten. You know, the original source of your salt is sea, the sea, because that is where your table salt, sodium chloride, that is where it's gotten from. So what they simply do is they put um, salt water, they store it in tanks and then they evaporate. By the time they evaporate, the water leaves and then the salt is left. And they can add some maybe vitamins or certain like iodine and other things to the salt before packaging it. for consumption. All right, so that is evaporation to dryness, and you also use that in Gary processing industry. Then let's talk about sublimation. Sublimation is the process by which a solid substance changes state from the solid state to the gaseous state without going through the liquid state. Normally, a solid is meant to dissolve. Are you with me? A solid is meant to dissolve into liquid, but there are certain solids that can change state directly from solid to gaseous state without passing through the liquid state. That is what you call sublimation. So there are certain compounds that have the ability to sublime. Example of such substance is ammonium chloride. Take note of that. Ammonium chloride has the ability to sublime, meaning that it can change from solid to gaseous state without passing through the liquid state. Another example is your camphor. If you put your camphor in your wardrobe, you see that the camphor begins to reduce in size, and eventually it disappears, and you don't see the liquid of that camphor. So camphor is a material or a substance that can sublime. So they can ask you that when you combine certain mixtures together, for example, you have ammonium chloride, you have sand, you have water, you have all of that mixed together, and they ask you how can you separate it. The ammonium chloride will be removed by sublimation. You have sand and water. You can do filtration. Filtration means you use a filter paper, you filter out the sand, and then you have the water left, or you can simply do evaporation to dryness. So I've spoken about a couple of separation techniques. You have magnetization. Magnetization is used to magnetize materials that are maybe metallic materials. Yes, a metal can easily be magnetized by a magnet. So that is that about that. Now let's go to the next topic. The next topic I will talk about is the periodic table and periodicity. Periodic table and periodicity. Now, when we talk about the periodic table and periodicity, we are simply talking about the table that shows the arrangement of elements. Arrangement of elements based on their similarities. Arrangement of elements based on their what? Similarities. That is the periodic table. Now, the first thing you need to know about the periodic table is the periodic law. They can ask you what is the periodic law. All right? They can ask you what is the periodic law. The periodic law states that the properties of elements on the periodic table is a periodic function of their atomic number. I repeat that. You might want to write that down. The periodic law states that the properties of elements, and when we say properties of elements, we are talking about chemical and physical properties of elements, are periodic functions of the atomic number. So what does that theory, what does it mean? It simply means elements are arranged on the periodic table in order of increasing atomic number. So they can ask you that according to the periodic table, elements are arranged in order of dash. What will be the answer? The answer will be their atomic number, not atomic weight, not mass number, not molar mass, but atomic number. I hope that is clear to everybody. So the periodic law states that elements are arranged in order of increasing atomic number. Okay, I have some questions here based on the topics that I've treated so far. Now, let us try to answer some of these questions. I hope you are following. This question says, in the periodic table, the arrangement is in order of their dash. A. Atomic weight. B. Molecular weight. C. Atomic numbers. D. Isotopic weight. What will be the answer, please?
Atomic number.
If you are following me, what will be the answer? You once again. I said in the table, arrangement is in order of their dash. A. Atomic weight. B. Molecular weight. C, atomic numbers. D, isotopic weight. What will be the answer? Atomic number. Correct. Rakib. That is very correct. So the answer is atomic number. Now, before we continue, another thing I want to talk about before I leave that topic of periodic table, let's now talk about periodicity. All right, let's talk about periodicity. What is periodicity? Periodicity is simply the variation in periodic properties. How does the periodic property vary across the period and down the group on the periodic table? That is what you call periodicity. Are you getting me? How the periodic property varies across the period and down the group on the periodic table. That is periodicity. When we talk about these periodic properties, what are the properties that we are talking about? Number one, thermal and electrical conductivity. That is the first property that I will be talking about. I will explain to you and I will give you shortcuts that you can easily use to answer questions on in your exams. So the first property is thermal and electrical conductivity. Now, this thermal and electrical conductivity is only restricted to metals. So you can only find these properties amongst metals because they are conductors of heat and electricity. So thermal conductivity means ability to conduct heat. Electrical conductivity means ability to conduct electricity. All right, so that is what you find in metals. And if you look at the periodic table, you see that groups 1 to 3. So how many groups do we have on the periodic table? If you are there, you can please drop your answer. How many groups do we have on the periodic table? The periodic table actually is made up of 8 groups. 8 groups and 7 periods. 8 groups and 7 periods. Now, if you look at some textbooks, they will tell you that the periodic table is actually made up of 18 groups. Okay, but there are actually 8 groups. However, between group 2 and group 3, you have 10 other groups. Yes, 8 groups. You have 10 other groups, all right, which are called the transition metals. The transition metals. So if you add the 10 to the 8, that is the 18. So that makes it 18 groups, but it's actually 8 groups. All right. Now, the group 1 and group 2 elements, all right, group 1, group 2 elements, they form the S block. The group 3 to group 8, they form the P block. Between the group 2 and group 3, there are 10 blocks, like I said, or 10 groups, like I said, and those 10 groups, they form the D block, which are also called the transition metals. And then you also have the block. You have the F block, which occupies the last 2 periods, all right, in the periodic table. Now, I was talking about periodic properties. I said the ability to conduct heat and electricity is only restricted to the metals. That means between group 1 and group 2 and 3, because group 1 to 3 are metals. Okay, group 1 to 3 are metals, group 4 are metalloids. Then group 5 to group 8 or group 0, they are non-metals. So when we talk about this ability to conduct heat and electricity, it is only found in metals and it's between group 1, 2, and 3. So this property, I want to ask you, is it increasing between the metals? They can ask you. They will ask you that this particular property, is it increasing or decreasing? Now take note of this. When a property is increasing across the period, then it is decreasing down the group. I want to believe you know what periods and groups are. Okay, so let me also talk about that before I continue. What are groups? Groups are vertical arrangements or columns. Vertical columns. Those are groups. All right. So when we say vertical, vertical means from up to down. So members of the same group, they are arranged vertically in the column. And what do they have in common? Members of the same group, they have the same number of electrons in the outermost shell. I repeat that. Members of the same group, they have the same number of electrons in the outermost shell. That is what you call valency. So they have the same valency, they have the same number of electrons in the outermost shell. That is members of the same group. And because of that, they have similar chemical properties. What does that mean? The properties of every member of the same group, they are similar. Their chemical properties are similar. And because of that, they can take part in similar chemical reaction. They can take part in what? Similar chemical reaction. So what, let me give you an example. Group 1, for example, I have sodium in group 1, there is lithium in group 1, there is potassium in group 1. So sodium and potassium, they can take part in similar chemical reaction. And what are the other elements in group 1? Apart from lithium, apart from sodium, apart from potassium. Who can tell us one or two other elements that are in group 1? If you know it, please, you can type it in the comment section. Let me see. What other elements are in group 1 of the periodic table? Apart from lithium, apart from potassium, apart from sodium. Okay, so in case you don't know, let me give you an acronym that you can use to remember. The acronym is RCF. RCF. What is RCF? R for rubidium, C for caesium, F for francium. Let me repeat. These are also members of group 1, RCF, which is rubidium, caesium, and francium. These are the other members of group 1 elements. Now, all of them, they have similar chemical properties and they have the same number of electrons in their outermost shell, right? So that is that about that. So then when we talk about periods, periods are horizontal arrangements of elements. So periods are what? Horizontal arrangement. When we say horizontal, that means across like this in rows. Columns are vertical, rows are horizontal. So when we say periods, periods are horizontal arrangements of elements on the periodic table. And what do members of the same period, what do they have in common? Members of the same period, they have the same number of electron shells. They have the same number of shells or orbitals. Yes. So members of period 1, all of them, they have just one shell or one orbital. If you go to period 2, everybody in period 2, they have the same number of shells. They all have two shells. If you go to period 3, they all have 3 shells. If you go to period 4, they all have 4 shells. Are we following? Now let's talk about another property of members of the same period. What other property do they have? Members of the same period, their atomic number increases successively across the period. What does that mean? What that means is that the first member of the period, so let's take for example, if you look at period 2, the first member of period 2 is lithium. The second, and lithium has atomic number 3. The next is beryllium, then boron. And if you look at the atomic number 3, 4, 5, it's increasing. So that's one property with members of the same period. Then another property with members of the same period is that their valency increases across the period. Their valency increases what? Across the period. What does that mean? The valency of the first person in that period is 1. Then the valency of the second person is 2, 3, 4. It increases like that. I hope that is clear. So that is group and period. Then this is a key or an acronym that you can use to remember which one is vertical, which one is horizontal. Groups are vertical, VGC. What is VGC? VGC, in Lagos, VGC is Victoria Garden City. But in chemistry, VGC means groups are vertical in chemistry. That's VGC, vertical groups in chemistry. Then pH is Port Harcourt. pH means period is horizontal. All right, so horizontal is period. That is pH. Now let's go back to periodic property. I have mentioned electrical and thermal conductivity. The second one is melting and boiling point. This melting and boiling point is higher among the metals. Are we together? Okay, Miracle. I can see you said, can we talk about physics? Don't worry. We are going to schedule the class for physics as well. Don't worry. Once we are done with this chemistry class, we can have physics class as well, right? So let's continue. Now, when we talk about melting and boiling point, it is highest amongst the metals. So amongst the metals, it increases across the period among metals. That is why elements in I hope you are listening. I hope you can hear me now. Oh, it seems you could not hear me. I've been muted since. It is well.